Now that we know that both Sn2 and E2 reactions can happen, how do we make sure that the E2 product is the major product? Well, steric hindrance is the main factor in this. We can sterically hinder the nucleophile in the situation. So for example, with potassium tertiary butoxide, which looks like this, where we have a tertiary carbon attached to an oxygen that is negatively charged, this nucleophile has a tertiary carbon right here. So this is a tertiary carbon attached to our nucleophile. So the oxygen with the negative charge is a really, really weak nucleophile because it's structurally hindered. However, it's still a strong base. It doesn't affect its basicity. This steric hindrance does not affect the fact that it's a strong base. So this will prefer mainly an elimination reaction. Now, the two alpha hydrogens that we have here, we have at least one alpha hydrogen on this carbon and at least one alpha hydrogen on this carbon. So we can have up to two elimination products. We can have one where it takes away this hydrogen and we get this right here, or we can take away this hydrogen and we can get a product like this. And so those are our two products. Now over here in this next example, we structurally hindered the substrate. Now if you notice, this is still a secondary carbon. So you're telling me like, hey, how is this structurally hindered? Well, look at the neighbor. The neighbor is a tertiary carbon. And because it's a tertiary carbon, this actually slows down Sn2 reactions a whole lot. One tertiary neighbor can affect Sn2 reactions quite a bit. And so we still have an Sn2 product here, but our major product is our elimination product. So we have one alpha hydrogen over here, at least one, and we have exactly one alpha hydrogen over here. And so if sodium hydroxide attacks any of these two hydrogens, we can get up to two products. We can have this product right here, and we can have this product right here. And if you want to label these as well, you can call this the Hofmann product because it's the less stable alkene. This one is the Zaitsev product, and we'll get into a bit about how we can manipulate getting either of these. So Hofmann again, and this is your Zaitsev product. And then with this one, we're actually only gonna get one product. We can't do Sn2 because over here we have a tertiary carbon. And so Sn2 reactions don't usually happen on tertiary carbons. And then again, we have at least one alpha hydrogen here, at least one over here, and at least one over here. However, if we do an elimination on either of these, our only product is going to be a geminal alkene. And so it's going to be disubstituted geminal alkene. And that's literally all there's going to be to it. And so, just to reiterate what we just did, steric hindrance is the main factor that will prefer elimination reactions over Sn2 reactions.